Hey, AP Computer Science kids. This video is a continuation of the Constructors review. So we left off on number 13. We have a public class item inventory. Inside this class, we have one instance variable of num items, a constructor that's public item inventory. And inside that constructor, we assign num items the value of the parameter num. And we have one method, public update items, that takes one parameter new num, and it changes the number of items to new num. And the question is, which of the following best identifies why this class does not compile? So our options are the constructor is missing a return type. This is false because constructors just don't have return types. So by default, a constructor is just public something. B, the update items method is missing a return type. C, the constructor should not have a parameter. That's also not true. A constructor can have a parameter, so this is going to be false. The update items method should not have a parameter. That's also false. A method can have a parameter. And the instance variable num items should be public instead of private. That's also false. We generally want instance variables to be private. So just by process of elimination, we should get that B, the update items method, is missing a return type. And then if we go back and look at this method, it is a method, and so it should return something. Else we're going to get a conflicting message of our class either needs to be named update items. So here where we have item inventory, this would need to be update items to match this, and then public update items would become a constructor. But since our class is item inventory and we have an item inventory constructor, this method needs some sort of return type, be it void or int, boolean, double, something else after that. It needs to have a return type. So again, the answer is B because the method is missing a return type. For number 14, we have the method, let's see, we have the bugs class, which is intended to simulate variations in a population of bugs. The population is stored in the method's int attribute. The get population method is intended to allow methods in other classes to access a bug's object's population value. However, it does not work as intended. Let's go through our little amount of code. So we have the class, we have an instance variable of population, we have a constructor that takes one parameter, and we set the instance variable population equal to P. And we have a method that returns an int value of population. And the question is, which of the following best explains why get population does not work as intended? So if we look at our options, so the get population method should be declared as private. That's going to be false because methods always need to be made public so they can be used by other classes. The return type of the get population method should be void. That's going to be false. The whole point of a get method is to have a way to get the value inside of an instance variable that is private. The get population method should have at least one parameter. That's going to be false. If you were going to set the population, you would need a parameter generally, but the get population, it only has one function, and that's to return the population. So C is going to be false. D, the variable population is not declared inside the get population method. That's also going to be false. An instance variable needs to be declared before the constructor. So again, by process of elimination, we get down to the instance variable population should be returned instead of P, which is local to the constructor. That's going to be true. If we go back and look at this, remember, if we want to get the population, we actually need to return population because P is just the parameter that's passed to the constructor bugs. So population equals P. That means that what lives outside of this constructor is the variable population, not the variable P. So this should return population instead, and then it would compile just fine. So that's why the answer is E. Number 15, we have, let's see, we have a public class fish tank. We have 2 instance variables of gallons and salt water. We have a fish tank constructor that takes in gals and SW, I'm assuming for salt water, as 2 parameters. We have a method that returns the number of gallons, and we have a Boolean method that returns a string salt water and it returns a string fresh water. So that alone should tell you why this class does not compile. The method is of type Boolean, meaning that we have to return a Boolean value, but the return here is a reference to a string, and this return is also a reference to a string. So this is not going to compile because we're just returning the wrong type. And so here, where are the answer choices? Get this out of the way. So we're looking at A. The value returned by, if we're looking at the options, I mean, we have the value returned by the get gallons method is not compatible with the return type of the method. Well, that's not true because gallons is a double and this method is a double. The value returned by the is saltwater method is not compatible with the return type of the method. That's going to be true. We don't have to like go through the rest of the options. This is not necessary. So for number 16, we have a public class player. We have 1 variable, instance variable for score. We have a public get score, and we just return the score. And we don't have any reference to how the constructor was set up. And so the accessor method get score is intended to return the score of a player object. Which of the following best explains why this does not compile? So these are the sneaky kind of questions that appear on the AP exam. Like, it looks like everything is fine, but notice, then again, the class is player, public class player. And so down here, when we have public get score, generally, if we have public and then a method name, that's going to point to a constructor. So this class should be named get score based upon what we see. So that means that this method is missing a return type. So that's going to be why this does not compile. Whatever option choice that is, that's going to be, so get score is a double. So I mean, score is a double. So our method needs to return a double type. For 17, let's see, it's a long one. So we have this public class item, and inside that we have a private and ID, and we create a constructor where lowercase ID is the parameter and capital ID is going to take on that value. Then we have a method that returns the ID. We have a void method that adds an item to a collection C, and apparently there's some method C.addItem. And then in an entirely different class, we have an item collection that takes last ID as a parameter, and we have public void add item, which is the method that is used in the public class item. And if the ID is equal to the last ID, you're going to say that ID value is rejected. And then if not, if the ID value is different, you're going to say ID is the ID, whatever the ID number is accepted, and they don't show the constructor for this. So a couple things is inside the else method, you first set last ID equal to the ID that's being passed to this that was previously rejected, and then you print that value and update it. So we have this item I equals new item 23. So that means the ID number is 23. and we have item J, the ID number is 32. And so we're gonna have item C equals new item collection. And what we're trying to do is add items I and J to the collection. So when we run I.add to collection, so let's see, that void method add to collection here is going to attempt to add 23. And so 23 is going to be added by default because there's no last ID right now. So we're going to get initially, so this condition won't trigger because there's no last ID for 23 to actually equal. So the else condition is going to trigger. Last ID is going to be updated to 23, and we're going to have ID 23 is accepted. Cool. So then J, which has a value of 32, is going to be passed. Well, 32 isn't equal to 23. And so this won't trigger again. This is going to happen. So now 32 becomes last ID, and ID 32 is accepted. We try to add J back to the collection again. Well, in this case, 32 is going to equal 32. So we're going to get 32 is going to, ID 32 is rejected. And then we're going to try to add I to the collection, which is going to be 23, not equal to 32. So this won't trigger. This condition triggers where last ID is not going to be 23. And so what we should get is accepted, accepted, rejected, accepted. And I don't know which answer choice this is, but let's say we said accepted, accepted, rejected, accepted. So that's going to make A the correct answer. This is one where I would recommend you type this out to see what happens. But again, the explanation is just the constructor we don't see, we assume that it takes in last ID as a parameter when we create this. So when these methods are already called, it has some value set for last ID, which again is a pretty big assumption to make without seeing some code, but College Board is gonna do what they wanna do. Number 18, we have, in the toy class, the raise price method is intended to increase the value of the instance variable price by the value of the parameter surcharge. The method does not work as intended. We have a public class toy, 2 instance variables, name and price, a constructor that has 2 parameters, one for a name and one for a price. Name equals N, price equals P. Then we have this public void raise price and the double surcharge. Now remember, void methods don't return anything. So that's the first issue, is that here, this return statement just does not need to be here because void methods do not return anything. So then which of the following changes should be made so that the class definition compiles without error and the method raise price works as intended? Well, one, either this needs to be changed to a double and we return price plus surcharge, or, I mean, if you want to you want to increase the value. So yeah, this is going to need to be changed to a double. So here our answer choices are replace line 14 with surcharge plus equals price, replace line 14 with price plus equals surcharge, replace line 14 with return price plus equals surcharge, or replace line 12 with public raise price double surcharge, or E, replace line 12 with public double raise price double surcharge. Since we just want to change the value, we don't actually need to return the value. There's nothing actually wrong with option E. It could work if you had some variable pointed to be this, but since you don't and you just want to change the value, you would want to choose B as the correct answer because it's just going to do price. And remember, the plus equals means add to the price, whatever the current price is, add the value of surcharge and replace price with that new value. So you would use 14 because it's a void method and you want to change the value without actually having to return the value. But again, you could construct some code where E would work out just fine, but generally we would go for option B by leaving this as a void method. For 18, for 19, we have public class something, private static int count. 19 is one we'll talk about in class because it uses this static int. And the explanation behind this is going to be longer than I want to take up in this video. So 19, put a flag on it. Remind me about it in class. The answer is that the answer is going to be 1 because this static thing won't be changed inside the constructor. But we'll talk more about that in class. Number 20, we have a public class tester, and we have a private int num1, private int num2, missing a constructor. The following statement appears in a method in a class other than tester. It is intended to create a new tester object T with its attributes set to 10 and 20. So we have tester T equals new tester 10, 20, close parentheses. So the constructor is this call to the new object tester is set up properly, and we need to just come up with a constructor that will actually make this work. It should be pretty straightforward. So remember, your parameters need to equal your instance variables need to equal the parameters passed to the constructor. So that means that on the left side, we need num1 and num2 equal to something. So if we have a public tester, we would want num1 to equal the first and num2 to equal the second. A is the correct answer, but we can go, talk about why the other 4 are not correct. So if we have public tester, int first, int second, num1 equals 1, num2 equals 2. Well, this is incorrect because there are no parameters 1 and 2. Also, you wouldn't actually be able to use 1 and 2 as parameters because they're already values and you need variables here to be parameters. For C, we have first equals 1, second equals 2. It's the same issue. You're setting a parameter equal to some fixed value, which is fine. It just won't actually return anything that's useful, and the instance variables won't be updated. For D, you have public tester, int first, int second. First equals 10, second equals 20. Again, that's fine, but it doesn't actually change the value of the instance variables that we need. So that won't work. And lastly, for E, we have public tester, int first, int second. First equals num1, second equals num2. It's almost right. It should just be the other way around. Num1 equals first and num2 equals second. So A is the correct answer because it has the instance variables updated with the values of the parameters of the constructor. Number 21 is, let's see, we have, that's a pretty long, we have 2 classes. We have a menu item class where you have a double price, constructor for the menu item that takes 1 parameter. The price is whatever you pass to the parameter. You have a double that returns the price of the menu item. You have a void method that's called make it a mill that turns into a combo. And then this combo mill equals new combo. Now this word means, remember we said this is the current object. And then you have this public class combo. So you have private double combo price. Public combo is going to take a single parameter. Combo price equals item dot get price plus 1.5. And then you have a public double get combo price and you return the combo price. The following code segment appears in the class. You have menu item 1 equals new menu item 5.0. So initially we have a menu item that costs $5. And then on that object, you call the method make it a mill. So now you have public void make it a mill. So now you're gonna have a combo mill equals new combo of this current object with this object 1. So right now we have 1 as the, we'll say a number 1 combo. So you have new combo 1. So now we jump into our combo class, and we're going to have the combo price is item.getPrice, which we can do this because we have a method that returns the price. So we're gonna have 5 plus 1.5, and then system.out.println 1.getPrice. So the getPrice method is going to return the value that is 5 plus 1.5 because we changed the value of the so we changed the value of the item based upon it being a mill because we have price equals mill.getCombo price, and the void method updates that. So we're expecting to get 6.5 as our answer, and that's going to be correct. Now again, this all works pretty smoothly because we have this get price method that is public, and we're not trying to actually change the value of the instance variable price through some dot like combo.price equals. We're not doing that inside the code. We're doing that inside of a method that has access to that variable. So the answer is 6.5. Number 22 is another one of these convoluted class instances where we have class C equals new class 1, C.init, and system.out.println C.getVal. So let's go through this. We have a class 1 where we have an int val1, and we have a public class, and that class has a single parameter where the value 1 is just equal to 1. We have a void method that creates a new class 2 and calls the c2.init method with the current object and val1 as the parameter. And then we have this public void update, which we'll talk more about once we go through this. We have a public void that's going to update by val1 minus equals whatever x is, and then public int get val returns val1. All right. So in class 2, we have a private int val2 as a 1 instance variable. We have a constructor. Val2 is going to be default equal to 2. And we have a public void in it where you take a whole object as 1 parameter, and the second parameter is some integer. And then for that method, you call c.update whatever val2 is plus y. So val2 is going to be by default 2 when we call this, and add in whatever this is, and when you call the update method, you're going to go back to val1 minus equals x. So when we create our object class 1c, so right now what we have is an object where it has a single variable where we know val1 equals 1, and then we call this method c.init. So what happens when we call this method is here we're going to have a C2 object where for C2 you have val2 equals 2. So now we have an object where here locally val2 is just going to equal 2, and then we're going to call c.toInit on the current object, which is C. So we're going to have C in val1, which is 1. So now, well, I'm sorry, no, it is 1. And so now we take this c.toInit method and jump into here. So for the init method in class 2, you're going to take the object from class 1, which is just C, and call the method init on this with the variable 1. So now we're going to have c.update val2 plus y. So that's going to be 2 plus 1, which is 3. And so now we're going to call this update method with the integer 3 passed, and val1, which equals 1 minus equals 3. So 1 minus 3 is negative 2, and then update val1 with that. So what's printed here is just -2. It's exactly what you think. And all of this works because we have methods that get and return values of these two different classes. So it's just following along with what happens. Now again, it's one of these convoluted things that you wouldn't actually do as a programmer, but you know, College Board is testing to see if you can follow through this. So again, the answer is just -2 because we just walked through what the code tells us to do. 23, it's a pretty straightforward question. We have a class called SumClass and private int A, private int B, my A, my B, and private int my C. They don't show the constructor. We have a method public int get A returns my A, public void set B changes the value of B. And the question is, which of the following changes to some class will allow other classes to access but not modify the value of my C? So that's what this get method does. It allows you to access the value of A without changing the value of A. This set method actually changes the value of B by updating it with this value. So we want a method that looks like the method for A. So we probably want like get C and return my C. So that's going to mean that we have public int get C return my C. This is going to be that we want as an answer. Private is never going to work for a method. Public void is going to change the value. Private void is going to be wrong because it's private and it's a void. And make my C public, that would allow access to the variable outside the class, so we don't want that. So just B is going to be the correct answer. And so then finally we have, that's a lot. Let's read through this. So one, the type is really small. So consider the bank account class. Below we have public class, bank account, public final string. We actually haven't talked about the final thing either. It just means that you're making this thing a constant. Can't be changed. Can't be changed and is always capitalized. So final constants are so things that marked final are considered constants, and they're by convention written as uppercase with all uppercase. And if you try to change the value somewhere else within the code, you're going to get some sort of error because you marked it as final. The final just means the value can't be changed. And again, the always capitalized part is just a convention so that when you're looking at the code, you know that, oh, this thing that's all capitalized, that's a constant, that value can't be changed. So we have two instance variables, a final constant account number. And again, when we say constant, we don't actually mean a number. We just mean whatever value is in this string in this instance can't be updated. We have a private double balance, and then we have our public bank account. So we have string, account number, and double beginning balance. And we have inside the constructor account number is equal to whatever this account number is, and balance is equal to that beginning balance. And we have a public Boolean withdraw, double withdraw amount missing code. So let's see, the class contains the withdraw method, which is intended to update the instance variable balance under certain conditions and return a value indicating whether the withdrawal was successful. If subtracting withdraw amount from balance, it would lead to a negative balance. Balance is unchanged and the withdrawal is considered unsuccessful. Otherwise, balance is decreased by withdrawal amount and the withdrawal is considered successful. And we are trying to determine which of these would work as intended. So if withdrawal amount is greater than balance, return overdraft, else balance minus equals withdrawal amount, return true. So the problem with one is that it doesn't return a Boolean statement here. So one won't work because the else method returns a Boolean, the if doesn't. So since this withdrawal amount needs to, we just need, Lights went off on me. So we need a Boolean here. For 2, if withdrawal amount is greater than balance, return false. Else, balance minus equals withdrawal amount, return balance. It's going to be not correct for the similar reasons to 1, because the if method returns a Boolean, the else method returns a value of balance. And so then when we get down to 3, if withdrawal amount is greater than balance, return false, which means you can't withdraw from the account, which is what we want. And then else, you can return, withdraw from the account. The balance is going to be updated with the withdrawal amount, and you replace that with balance, and then you return true. The most important part is that both the if and the else condition return Boolean values, because this is a Boolean method. So only 3 works, and that's going to make C the correct answer. All right, so this is about an hour's worth of me going through this stuff. If you have questions, watch the video, rewatch the video, talk to me in class, or type it up into Eclipse or whatever IDE you're using. See you in class.